So for example, this number here, the 3 is significant, the 0 is significant, the 9 is significant. The 0 is not significant because it's a trailing 0 is occurring to the left of the decimal point, and so there are 3 significant figures for this number. Here we see example of leading zeros. Okay, leading 0 is going to occur when it's before non-zero digits. It usually is in the format of 0.0 something. Captive zeros again are sandwiched in between two non-zero digits. Trailing 0 here is actually significant because it's to the right of the decimal point. So here we have 4 digits that are significant: the 8, the 0, the 2, and the 0 here. These leading zeros, of course, are not significant. So it's really important to understand significant figures and be able to determine how many significant figures there are. In your textbook, there's some examples. So I want you to make sure that you look at those examples in your textbook. Here I have some for you using my document camera. So here's an example. Here we have 6 non-zero digits. So we have 6 significant figures. Here we have 4 digits. We have 2 zeros that are sandwiched between 2 non-zero digits, so they're all significant. So we have 4 significant figures here. This example, we have a non-zero digit here. We have 2 zeros that are sandwiched in between 2 non-zero digits. And then we have a trailing 0 that's also significant because it's to the right of the decimal point. And so here in this case we have 6 significant figures. For this example we have 3 significant figures. Here we have leading zeros that are not significant. And then we have a trailing 0 that is significant because it's to the right of the decimal point. Okay, so these 3 digits are significant, so we have 3 sig figs here. Here we have a lot of trailing zeros. Notice these zeros are to the left of the decimal place, and so they're not significant. And so only the 1 is significant in this example, so we have 1 significant figure there. Again, I recommend you go to your textbook and look at the examples and go through all those examples so you understand significant figures. Now, with significant figures, there are rules, okay, to apply to use when you're calculating a number. Okay, so we'll talk about the rules, and then we'll learn about calculating density and do some examples there. And that way you're able to apply some of the information that you're learning. So here the rules for significant figures. When you add or subtract, you should round the result to the same number of decimal places as a number with the least number of decimal places. Okay, so the least precise value in terms of addition or subtraction. So the way I remember this rule is this. When I was in math as a child, in elementary school, I learned to add and subtract before I learned to multiply or divide. Okay, so adding and subtracting is pretty easy, compared to multiplying and dividing. So the rule is very simple with adding and subtracting, because all you're doing is for the final answer, you're going to trim or round off that answer using the least number of decimal places. Well, guess what? You don't really have to have a knowledge of significant figures in order to do this, right? So it's pretty simple. All you have to look at is the number of decimal places and use the value, the least number of decimal places for your final answer, and you're done. So it's pretty simple. Now with the second rule here, with multiplying or dividing, it's a little bit more complicated. Okay, it's not too complicated, but you have to have a knowledge of significant figures. So it says we should round the result to the same number of digits as the number with the least number of significant figures. So the least precise value in terms of multiplication and division. So when I multiply or divide 2 numbers, okay, the final answer, even though I may have, 5 significant figures on my calculator, I'm going to round off that answer, right, to the least number of significant figures that I have in my data set. So if I have one number that has 3 significant figures, and I have one number that has 5 significant figures, and I multiply them together, and I get 6 or 7 significant figures on my calculator. How many significant figures am I going to use? So I'm going to use the number with the least number of significant figures. So I would use the 3. 3 number, the answer with 3 significant. So it says if the digit to be dropped is less than 5, we round down and leave the retained digit unchanged. If it is 5 or more than 5, we round up and increase the retained digit by 1. Okay, and so if the dropped digit is 5, we round up or down, whichever yields an even value for the retained digit. Now, for the third rule, you probably already are familiar with rounding up or rounding down, right? If it's 5 or greater, you round up. If it's 5 or less than 5, then you round down. But this is the part here that was a little bit different from what I've seen in previous textbooks. So if the drop digit is a 5, we round up or down depending on if we get an even value for the retained digit. Okay, so you will see some examples of that in your textbook. Okay, that you might it might stump you a bit, but remember that this is for this rule that if it's 5, it could be rounded up or down if the digit is dropped, depending on whether or not the digit retained is even. If it is even, then you leave it. You don't round up, and if it's not, then you would. Okay, so here are some examples of rounding using appropriate number of significant figures. So it says the following examples illustrate the applications of this rule in rounding a few different numbers to 3 significant figures. Okay, so here's a number I want to round to 3 significant figures. So it would be 0.02. The zeros here are leading zeros, right? They're not significant. So I need 2, 8, and then 6. I need to round that 6 to a 7, right? So this would be your rounded value here. Of course, 7 is greater than 5, and so you would round up here to 0.0287. For the second example here, we're rounding to 3 significant figures. Again, this would be 18.3. This is a 3 here. It's less than 5, so we don't round up. We leave it as is. So it's just 18.3. The third example here, it's 6.87. This is a 5. Okay, so we're gonna round up because this is not an even digit, right? So we're gonna round up to an even digit of 6.88. This is the rule 3 part at the very end where we're talking about if it's 5 or greater. Well, it's 5, but you can round up or down depending or not. You want the retained digit to be even. 7 is not an even number, so we round up in this case. Okay, if it were 6, we would leave it and we would not round up. In this case, we do round up because we want the retained digit to be even. Okay, last example here. We need 3 significant figures. 92.85. Here, we're not going to round up because the 5 is not being retained. The 8 is going to be retained. It's an even number, so that's why we retain the 8. Okay, and not round up to 92.9. Okay, so now we're going to have examples of density and how to calculate density. So here's a figure from your textbook that shows you a mass of a rebarb. So there's basically 2 different ways to determine the density of an object. It depends on the shape of the object. So if you have a perfect cube, you can determine the density using a formula for the volume. So I'll discuss that in just a moment. But in this case here, we're talking about finding the density of an irregular object. Okay, so how do we do that? We do that by what's called volume displacement. So we add some water to a graduated cylinder, and then we take an irregular object and put it in the graduated cylinder, and then measure the volume again. So here we have the initial mass of the rebarb. We have the final volume of the liquid in our graduated cylinder, and then we have the initial volume. Okay, so the first step would be to find, of course, the volume of the irregular object. So the way we would treat this is we would take the difference between the final and the initial volume to figure out the volume of the irregular object. And then once we do that, we have the mass and the volume. All we have to do is divide. And so here I've taken the final minus the initial volume to get a total volume of 8.9 milliliters. That's the volume of the irregular object, the rebarb. And I have the mass, and now I just set up my equation for density, which is mass divided by volume. And then so I input my numbers into my calculator to divide. And this is the numbers I get from my calculator. Now that is not the density of my rebarb because there are way too many significant figures here, right? What is the rule when we multiply or divide? Well, when we multiply or divide, the rule is we take our final answer should have what? The least number of significant figures. So here if we look at how many significant figures there are for mass, there are 5 significant figures, right? There are 5 digits there that are non-zero digits, and so they're all significant. And here for volume we have 2 digits here, 2 significant figures. So basically we're going to report the final answer with the least number of significant figures. So here there's 2 significant figures here, so our final answer should be 7.8 grams per milliliter. That is the density of our rebarb. Okay, so remembering the rules when I add or subtract, if I'm going to add 3 numbers together, so here I'm adding 1.43 centimeters plus 0.0047 centimeters plus 1.5 centimeters. What I get in my calculator is 2.9347 centimeters. However, remember our rules from adding or subtracting. We're going to use the least number of decimal places when we add or subtract. So here, for our first number, we have 2 decimal places. Here we have 4 decimal places. And here we have 1. So I would not report 2.9347 centimeters as my final answer for this question. My answer should be 2.9 centimeters. I should only have 1 decimal place, and that's because I only have 1 decimal place here. With adding or subtracting, I always use the least number of decimal places. And so since I only have 1 decimal place here, I'm going to report that 1 decimal place for my final answer. Okay, so what if we have an object that we're going to assume is in the shape of a rectangle, okay, or like a rectangular prism. So in that case, instead of using volume displacement to determine the volume of the object, we can just simply calculate it using the volume of a rectangular prism. So, for example, here we have a question. It says a common bathtub. It gives us the dimensions and decimeters, the length, the width, and the height of the tub, assuming that it's rectangular. Calculate the volume in liters. And so what I would do is basically just, I've listed the length, the width, and the height here. And then to find the volume of a rectangular prism, it's just length times width times height. And so I go ahead and I do that. So I multiply my dimensions together. These are all decimeters. And so this is what I get in my calculator. Okay, so remembering we're talking about significant figures, what's the rule whenever I multiply or divide? And so that is to use the final number should have the least number of significant figures. So here I have 4 significant figures, right? Here I have also 4, and here I have just 3. So I'm going to report my final answer using 3 significant figures, and so that would be 202 cubic decimeters. Okay, and because 1 cubic decimeter is equivalent to a liter, that's also 202 liters would be the volume of the bathtub. Now, if I wanted to determine the density, which is what they ask next. They ask for the density of the bathtub.